So you've probably heard this idea floating around, right? That AI is teaching itself to get smarter, constantly discovering new ways of thinking all on its own. It's a pretty exciting thought. Well, let's dive into that, because some new research suggests the reality is, well, it's a lot more surprising than you might think.
I mean, we all remember the headlines about AlphaGo, right? This AI that learned to play Go and just came up with these incredible superhuman strategies nobody had ever thought of. So the big question on everyone's mind is, are large language models, the brains behind things like ChatGPT, are they doing the same thing? When they solve a tough math or a coding problem, are they actually inventing brand new ways to reason?
Okay, so the main technique that's supposed to be driving all this is called reinforcement learning with verifiable rewards, or let's just call it RLVR. The concept is actually pretty simple. You give the AI a math problem, it gets the right answer, it gets a reward, like a point. It's wrong? Nothing. And the whole goal for the AI is to just keep training to get as many of those points as possible. The common belief here is that this whole process forces the AI to discover new, smarter ways to think.
And that brings us to this really popular idea, the self-learning AI.
But this is the critical question, the one that some very smart researchers started asking. Is this whole reward-based training thing actually creating new skills? Is the AI really inventing novel ways to solve problems? Or is it just getting a whole lot better at using what it already knows? Just finding answers that were kind of buried inside its brain all along? And this is where the story takes a turn. Because what they found was, yeah, not what anyone expected.
So to really figure this out, they used this super clever measurement called the pass at K metric. Instead of just checking if the AI gets the answer right on its first go, this metric asks a much deeper question. What's the chance the model can find the right answer if we give it a whole bunch of attempts, like K number of tries? This lets you see the model's true potential, not just its first best guess.
And when you just look at the first try, well, the results are exactly what you'd expect. The trained model, the one that went through all that RLVR, it gets a higher score, it's more likely to be correct right out of the gate. Looks like a clear win, right? So you'd think that's it. Case closed. The trained model is just better. But what happens if we give them more chances? Like, a lot more chances. And this is the big reveal, the moment that changes everything. When you give them tons of tries, say 256 attempts, the whole thing flips on its head. The original, untrained model, it actually ends up solving more problems. Its potential is actually higher. You can see this really clearly in what the researchers called the crossover effect. So look at the trained model in blue. Yeah, it starts out higher on that first try. But look at the gray bar, the original base model. It starts lower, for sure, but give it enough attempts and its total potential, its ability to eventually find the right answer, actually goes higher than the trained model. It overtakes it.
So what's going on here? Well, the researchers came to this incredible conclusion, and I'm quoting them here. All reasoning paths in the RLVR model are already present in the base model. In other words, the training didn't invent a single new way of thinking. It just made the model better at finding the paths it already knew.
Okay, to really get your head around this, there's a perfect analogy: the librarian versus the library. So think of the base model, the original one, as a massive, complete library. It's got every possible book on its shelves, every single reasoning path, every possible solution. It's all in there somewhere. The knowledge is just immense.
Now, that trained model, that's our hyper-efficient librarian. This librarian knows exactly where the most popular books are. You ask for one, bam, they have it in a second. But, and this is the key, in becoming so specialized, they've basically thrown away the card catalog for everything else. They're amazing at the common stuff, but they've lost the ability to find those more obscure, less common solutions.
And you want to see the proof? The data backs this up perfectly. Look at this. The base model, the library, could solve over 13% of problems that the trained model just couldn't. Now look at the other side. How many problems could the trained librarian solve that the library didn't already have? 0. A flat 0. Not a single one. The librarian couldn't find a single book that wasn't already in the library.
So if that kind of training doesn't actually create new skills, then how can models grow? How do they get genuinely smarter? Well, there are basically two different paths to improvement. On one side, you've got RLVR, which we now know refines what's already there. It's our efficient librarian. But then there's another method called distillation. This is totally different. Here, you use a bigger, smarter teacher model to create a bunch of great examples, and a smaller student model learns from them. It's not refining, it's inheriting new knowledge. It's like the librarian getting a delivery of new books from a bigger, better library.
And this chart makes that difference so clear. The gray bar is our starting point, the base model's potential. The blue bar, the one trained with RLVR, is actually a little bit smaller. The potential got narrower. But then look at the green bar, the distilled model. Its capability shoots way past the original limit. That is true growth. It genuinely learned something new.
So what's the big picture here? What does this mean for the next leap for AI? Okay, let's pull it all together. What we've learned is that the training we thought was about invention is really about efficiency. It just sharpens the AI's ability to find answers it already kind of knows. And this comes at a real cost. It actually narrows the model's range. It seems like a model's reasoning power is fundamentally limited by what it had in the first place, in that base model.
And that leaves us with a really big, fascinating question to think about. If today's AI training is more about refining than creating, then what's it going to take to get to the next level? What kind of breakthrough is needed to unlock truly new, truly independent reasoning in an AI?